1521 number can be anything. It's like socket.
No, 1521 is a number which is a standard number reserved for Oracle listener. But the security folks, audit people, IT audit people will tell you that everybody knows that your listener is, the Oracle listener starts on 1521. So don't start your listener on 1521, start it on some other port, so that it will not be very obvious to the users that, okay, behind this port, Oracle server is there. Because there are certain Unix commands or networking commands, for example, nmap. Nmap is a command. I would run that on the DOS prompt, Unix prompt, and an IP address 172.24. Let us say 0.240. If you run this command, nmap command will scan each and every port that is open on this machine, and it will give you the list of all the ports that are open. Port number 80, that means immediately I know that on this server there is a web server running. Port number 21 is open. If it is open there, I would know there is an FTP server running, and if it says port number 1521, then the Oracle is running. So usually IT guys say don't put it 1521, put something else. So likewise, at least it would not be that obvious for the outsider to find out, oh, there is an Oracle server running there.
So it can be any number.
It can be any number. It should be above 1024. Yeah, 1024. Okay, so now troubleshooting this thing. It is very easy to configure the client as well as the server, very easy. But it becomes little challenging to troubleshoot. After doing all those things, they will say that I am not able to connect to the database. This is a common complaint DBAs get. So what needs to be done? Troubleshooting. When the client says I am unable to connect to the database, usually everybody has a different way of approaching this. I would go with something like this. Number one, use the ping command. From the client side, ping to the server the IP address, so 172.24.0.240, or ping the name of the machine. In that situation, if the client side can connect to the server side, the ping will work. Ping is basically, what is the ping command? I think all of us, we know the ping command now, that when the ping command is fired, there is a certain set of bytes, usually 64 bytes, that are sent from your one machine to another machine. And if the another machine is alive, then it will send those 64 bytes back to me with a different header, and it will also print the total time that took for the round trip across. So that will tell you, is there any network latency. You should always know the time it takes usually to ping a machine on your network. Is it 20 milliseconds, 30 milliseconds? If you ping a server from India to Google, if it is outside server, I have seen it takes 900 milliseconds, sometimes 1000 milliseconds, but this local server here will be very fast. So that may kind of tell you that yes, we are able to ping, but it is little slow. Anything between 200 milliseconds is kind of a very acceptable range there. So ping to find out where client can connect to the server. So client and the server. Second thing is that even after ping works, you need to immediately check your TNS names file. TNSnames.ora is on the client side. On the client side, we are doing all these things on the client side. You check your TNSnames.ora file for that same information, the IP address of the server, the protocol TCP/IP, the port number, and the SID. Those should be exactly same as what you are trying to connect to. If there is any mistake over there, then the next step will not work. So this should be correct as per the instructions or as per the configuration on the server. If that is correct, then the third step is TNSPing. This is a Unix command again. It is provided by Oracle software. TNSPing, and then not the IP address but the connection string. Connection string. So for example, if my connection string is ABC, I would just type the command TNSPing ABC. What will happen when I type the TNSPing command, TNSPing ABC, at the client side, at the DOS operating system? Suddenly, this TNS ping command will find out the file tnsnames.ora in the network admin directory or in the tns_admin directory, wherever it is, that variable it is. And then from that it will find out those four things: IP address, port number, TCP/IP protocol, and the SID. And then it will actually try to establish a connection to the listener on the server. It will establish a connection to the listener on the server. Now, if the listener is running properly on that server, on that port number, and it is talking that language of TCP/IP, then listener will come back and say, yes, I got your connection, everything is okay. So this command will give you a lot of other information, and finally it will say okay. Once you see that okay, then it means your listener is up and running. So at least you can go from here to here. That is the second step of troubleshooting. Then the third step, even after that, you are not able to connect. How are you trying to connect, by the way? On the client side, you are typing the command SQL plus user ID, let us say U1, password is U1, @ the connection string is ABC. This is how you are trying to connect from the client to the server. And this command is not working, that's why we are doing all this troubleshooting. So even after TNS ping works, you are not able to connect to the database. That means there is some problem on the server side now. The client side problems are resolved, server side problems are there. What could be the server side problem? The server side problem could be one very classic problem, that yes, the listener is running, but the database is not up. Okay, so there is a database here. Database has not been started. Somebody has started the listener with the lsnrctl start command, but nobody has started up that database with the startup command. So if the database is down, you will not be able to connect to that. So obviously make sure that the database is up and running. So that is the next step. So now on the server side, so this was on the client side, on the server side, so client, and now on the server side. On the server side, you are going to check if database is running. And if the database is running, you should be able to connect to the database. But many times what happens, even if the database is running, even if the listener is running and you are able to contact the listener, you are unable to go to the database. What could be the reason? The reason,
User ID, password.
the user ID password could be another thing, yes. So check the user ID password, user ID and password, that you have wrong user ID password over there. Another thing that you should check your permissions. What permissions? That this user U1 does not even have the create session privilege. Create session privilege is the one that is required to connect to the database. So this has not been granted the create session privilege. That could be one of the problems. So check that one also. After checking all these things, even if you are not able to connect, and that could happen, and that does happen many times, it means there is some problem between the communication between the listener and the server, the database instance. So that is the problem. And what is that problem? It's a classic problem there, that listener is unaware of the existence of the instance. Listener is unaware of the existence of the database instance. So what needs to be done? Somehow listener needs to know about the database instance, and that process of letting the listener know about the existence of the database instance is called as registration. So remember this process, registration of a database with the listener. Registration of a database with the listener, if that has not happened, then listener is unaware of the database. Registration of the database with the listener. That means telling the listener that my name is Focus1, I am the database running on this machine, I am registering with you, please allow any connections that you get for me and send those to me by starting a dedicated server process. So this registration has to happen. There are two ways to do this registration. One is, now I will erase this thing. One is the dynamic registration, and one is the static registration. Again, let me repeat. Registration is the process of letting the listener know the presence of the database. Somehow listener needs to know that that there is a database called as focus 1, and therefore anybody coming from the client side will be handed over to the database by starting a dedicated server process. Now one listener can listen for multiple databases. So there is a database called as ABC and there is a database called PQR. Both of these databases, if they have registered with that one listener, then that one listener can send the connection sometimes to the ABC depending on what is requested from the client's tnsnames.ora file, because client's tnsnames.ora file contains the SID. It will be sent to ABC sometimes, it will be sent to PQR sometimes. So again, the point to remember, usually in many organizations this would be the structure: one listener and multiple database instances. You can have multiple listeners and multiple databases also, but in that case, note one point, that one listener can start only on one port. So don't start the second listener also on 1521. If you want to start the second listener, then start it on maybe 1522 port number. Now how do you start the second listener? You need to make the entry in the same listener.ora file with a different name. Okay, again use netca for that also. So this is the background of that. Now how to do the dynamic registration and how to do the static registration, that is something that we need to worry about. Now dynamic registration is the default behavior. What is the default behavior dynamic registration? It means that if the listener is running, and if listener is running on port number 1521, then by default the PMON process of the database is going to establish a connection to the listener and tell the listener that database instance ABC is up and running and please allow the connections. So that kind of information sent from the PMON of the database instance to the listener is called as dynamic registration. And if the listener is running on port number 1521, this happens automatically. We don't have to do anything special, anything extra for the dynamic registration has to happen. The only thing that we have to do is to make sure that the listener runs on port number 1521. Now if listener runs on port number other than 1521, then this database instance wouldn't know which port number the listener is running on. It wouldn't know which port number the listener is running on. So somehow this database should be informed that the listener is running on port number 1525, and that is done through an initialization parameter called as local underscore listener. Local underscore listener is an initialization parameter. Where do we write the initialization parameters? In the P file or in the SP file, depending on what you are using, init.ora file. So in that you are going to say local underscore listener is equal to, and then you are going to write some information which will look like the connection string information, and that will do the magic of registering dynamically with the listener. So I will exactly tell you the syntax of this, how this whole thing works. Actually, the easier syntax I will tell you: local underscore listener is equal to connection string. Is equal to connection string. So that means whatever connection string you have, let us say your connection string is PQR. Now we know what the connection string is. Connection string is a piece of information which is written inside which file? TNS names file. Now this TNS names file is not on the server side. It is on the actual client side here. Then why am I saying this thing? We need to create a tnsnames.ora file on the server itself. We have to create one more tnsnames.ora file on the server, and in that tnsnames.ora file, same information: where is the listener running, on what IP, on what port, and what TCP IP. Exact same information over there, and that is the connection string over there. And let us say you are calling that information with the connection string PQR, and then you just say local underscore listener is equal to PQR, which means now this initialization parameter will go in the tnsnames.ora file, find out the IP address, find out the port number and everything about that listener, and then it will do the dynamic registration. Basically, again, dynamic registration is telling the listener that I am the database which is running right now, please let the connections come to me. Okay, so done by two ways: by either default 1521 port number or through the local underscore listener. Any questions on this side? This is simple.
TNS names there on server side.
Oh,
TNS names.
TNS.
Have it on client side.
we have
It
it.
is-
So now this time it is acting as a client. Client is, what is a client? Client is any program which would like to communicate to the server, another program, server side, for some kind of information exchange. So here PMON acts as a client program which is trying to connect to the listener to send the information there. So PMON, and that's why PMON needs to know where the listener is running. To know where the listener is running, we need the tnsnames.ora file.
PMON is the file.
Huh?
PMON is the file.
PMON is the process. PMON is that process. PMON, SMON, LGWR, DB. Yeah, we did not talk about PMON. Huh? We talked about only those three processes: DBWR, database writer, then LGWR, the log writer, and then there are two other processes. Okay, I think we did not talk about that. Maybe that's why the confusion is. See that my typical diagram here. This is my SGA, and this is the DBWR process. This is the LGWR process. LGWR. Database writer is now written to the disk by DBWR, and then LGWR will write information from the log buffer into the redo log file. And then there are three other processes. One of them is checkpoint. We haven't seen too much about checkpoint. And then there is a process called as PMON. PMON stands for process monitoring. So it has certain information, certain tasks. We will see a lot about this PMON during the undo discussion. It is monitoring certain processes. And one of the tasks for this PMON process is to let the listener know that our database is up and running. So PMON, process monitor, and I will also mention the name of another one, which is SMON, server monitoring. This is for recovery process. We'll see a lot about this during the recovery. This is during the undo discussion. So let me recap now. Dynamic registration is done by the PMON process. It is the sending of the information to the listener that I am up and running. Please send me the connections. Now, how is the static registration done? Static registration is done by writing the information. So static registration is done by writing the information in the listener.ora file itself. Listener.ora file, we saw earlier that listener.ora file, which sits into network admin directory, contains the information about where to run the listener, on what port the listener should be running, what protocol it should be using. All that information is there in the listener.ora. Along with that, the information about the instance is also in the listener.ora. So in my next practical, I will show you how the listener.ora file looks like. In fact, again, my suggestion is don't change the listener.ora file. Use the netca to change this information in the listener.ora. So two types of information is written inside the listener.ora. One is actually about the listener, where to run, on what port, what protocol. That information is one section. And second section is about the static registration, which database is up and running, and what is the name of that database. Is it a 9i or 10g database? So that information is there in the listener.ora file. Now actually it will be more clear when you look at the actual files, and that is what we'll see now. ठीक है.